In our previous clips, we examined the correct way to combine render passes to recreate the original render. So here I have two renders which at first glance may appear the same. However, I want to use this to show you some of the things that can go awry in the process if you're not careful. Now, looking at these two viewers, we'll see that although the images appear the same, the text, which is just a text node I've added to help you see what's going on, looks slightly different. And a clue to that may be seen up here. Now, over here we have this viewer process. Now, a viewer process is also known as a viewer LUT. And a viewer LUT is nothing more than a magical pair of sunglasses. When I say magical, I mean that not only can they make images appear darker, but they can also make them appear brighter. So, with our sunglasses on this image, and our sunglasses off this image, they appear the same. But what happens if I take my sunglasses off and view this image here? Well, you can see the text actually looks the same, but our image looks way too dark. Now, why is this? Well, the reason this appears too dark is because the values are being viewed in linear color space. Now, presumably, like me, you're looking at some form of computer monitor. A computer monitor takes our linear data and applies a curve to it. It's just a matter of the way the hardware is designed, and therefore linear images will appear too dark. To compensate for this, we actually apply an inverse curve to brighten those images up. Now, in the render on the right, in viewer 2, we have actually burned that into the image. We have burned that into the data. So if I sample this box here, and I'm going to try and get the same box here, more or less the same, we can see very different values, much lower numbers as you would expect in the darker image, 0.28, 0.17, 0.10, 0.55, 0.44, 0.44, 0.35. But if I put my sunglasses back on, you will see that the data values do not change, which is what you would expect. If you remember, when you last put on a pair of sunglasses, the sun did not actually get less bright, less warm. You didn't actually switch out a light. It just appears darker. In this case, it appears brighter because we have these magical sunglasses. So to examine color spaces, I'm going to use something in Nuke, which is very handy for visualizing this data. I'm going to go to the node graph. I'm going to press the S hotkey and bring up my project settings. Go to the second tab, which shows our color settings. Now, let's just resize that to fit within the capture area. So, linear color space is exactly what we would imagine. A value of 0 maps to 0, a value of 1 maps to 1, a value of 0.5 maps to a 0.5, and so on. Now, our monitor has an sRGB curve. Let's have a look at that. So, as I said, our hardware is actually taking our linear values. So a value of 0 still maps to 0, and a value of 1 still maps to 1. But our middle values are radically changed. So our value of 0.5 in our linear image is being viewed by the hardware as something like 0.2. And so to get an image that actually appears to be 0.5, we need to actually have data that is around 0.7, slightly higher than 0.7. Well, what we can do is we can apply this same curve in the other way. So our magical sunglasses are actually taking our value of 0.2 and mapping it to 0.5. And they're taking our values of 0.5 and mapping them to 0.7 and a bit. And therefore, by doing the exact opposite of what the hardware is doing, we get something. They cancel out and we get our linear curve back. So there are some other curves that are very similar. Gamma 2.2 is basically an approximation of sRGB. It's slightly different. You can see the lines don't exactly match, but they are almost the same. Rec 709 is used within video, so a television and a DSLR. A P3 is not on this list, but it's used by cinema monitors, and there are various other color spaces associated with cameras which are very different, and we won't be looking at those in this course. So I'm going to close that, and I'm going to look at what we can do when we actually render this. So you could say, well, if I burn the color space colored in, I don't need these magical sunglasses. This is more correct. Well, possibly. In fact, a JPEG image or a PNG that you find on the internet will be in this color space because, of course, they don't know what you're looking at it in. You're probably going to be looking in a browser or a file browser or a web browser, and therefore you want the image to look fine as it is. But for compositing, we need to work in linear color space, so we need to wear our magical sunglasses in order to view the image correctly.